Alright, what's up, Algebra 2? Here we are with 7b, Summative Review. Note the directions, exact simplified form on the front, no rounding. Alright, getting to start off with a pretty easy one, hopefully. Log base 5 of x equals 3. Remember that the answer to a log is an exponent. So this 3 is going on top of base 5. 5 to the third power. 3 is the power of 5. That gives me x. So we have 5 to the third power equals x. 125. Okay. I'm actually going to slide over and do number 2. Even though we usually leave you all the evens. Okay, same deal. 125 to the 1/3 power equals x. So the 1/3 power is like the cube root. Okay, we just did the cube. So hopefully we can see the pattern there. This is going down smaller to be 5. Okay, and the reason that I wanted to do that one is so that now you can see what happens when I do negative 1/3. 125 to the negative 1/3. Okay, 1/3 power got me down to 5. Do you remember what the negative exponent does? It doesn't make the answer negative, it flips your answer. So it's going to be 1/5. It does say exact simplified form, 1/5 fractions would be preferable there, but 0.2 would not be wrong because it is a terminating decimal. It doesn't go on forever like that. Alright, on to number 5. We're taking that x on top of 25. Alright, so now we finally hit one where we cannot just type it in. Okay, we have to think. So 25 is 5 squared. And 125 is 5 to the third. So we're going to change both of these to be something with 5s. Power, parentheses, power. We multiply those powers. Okay, it looks pretty easy on this one. It doesn't really change. 2 times x is now 2x. But it's important to still do it because on the next one, we do have some multiplying to do. Okay, 5 to a power equals 5 to another power. That's only possible if the two powers are equal. 2x equals 3. X equals 3 halves, or 1.5. Alright. Moving on down to the next one. One fourth and 8. It's kind of tricky. Alright, 2 to the third power is 8. 2 squared is 4, but it's 1/4. It's flipped. Okay, so we're going to use a negative exponent. 2 to the negative second would be 1/4. Now we have power, parentheses, power. We're going to multiply. Take that negative 2 to both. Hey, thanks for coming in. And we'll take this 3 to both. 2 to a power equals 2 to a power. Oh, I lost my x over here. That's a negative 2x. That one equals that one. Okay, we're going to add 2x. 4 equals 5x plus 3 minus 3 and divide by 5. We got 1/5 for x. Number 9. Natural log of x squared minus 5 equals natural log of 4x. That is only possible if the inside parts are equal. If x squared minus 5 equals 4x. Okay, one of our favorite things to do with x squareds is to solve by factoring. Let's get that 4x over there. Minus 4x minus 5. We've been doing a lot of factoring lately, so hopefully we're getting to a point where we can maybe factor these without having to do the magic x. Not a big deal if you still need to, but what multiplies to negative 5 and adds to a negative 4? X minus 5 and x plus 1. Which makes our answers positive 5 and negative 1. Okay. Now we're going to kind of mentally walk through these. 5 squared minus 5 is 20. 4 times 5 is 20. So 20 equals 20, positive and equal. If I put negative 1 in there, negative 1 squared is 1, minus 5 is negative 4. Negative 1 times 4 is negative 4. They're equal, but they're not positive. Okay? Natural log is still a log, and on the inside we have to have positives. So, in order to say it's not going to work, you got to show me it's not going to work. Okay, and this will be negative 4, and that's negative 4. They're equal, but not positive. So that one is a no. Okay, we're not going to use that one, only going to use 5. Alright, if you need to rewind that and watch it again just to really absorb it, go right ahead. That's the best part about video Handke. You can pause and rewind them. Maybe adjust the playback speed on YouTube so I talk a little slower. Alright. Backside. Okay, on the backside here, we're rounding to 3 decimals if necessary. Okay, a lot of our worksheets were 2 or 4. Make sure you're paying attention to the directions. Log base 6 of something plus log base 6 of something else. Okay, it's not log equals log anymore, so I cannot do this equals this. They're on the same side and they're a plus, and they're the same log base. So we can put them back together as 1 log base 6 with multiplication. And now you might be saying, Mr. Handke, both the logs are gone and down to just 1. What do I set equal to each other now? Like we said before, this is not log equals log, so you're not going to do equals, okay? You're going to use log properties again. The answer to a log is the exponent. Okay, so 6 to the first power equals 2x squared minus x. Now we're going to get everything on the same side, minus that 6 over. And now we're going to solve by factoring. I am going to use my x this time, just because there's a number in front. Okay, 2 times negative 6, we got negative 12, and negative 1. We're going to go with negative 4, positive 3. That's going to multiply to negative 12 and add to negative 1. And now we do have to come back and divide by 2. X minus 2. And then bring that 2 up in front. 2x plus 3. Okay, zero product property. This times this equals 0. That means one of the two things had to be 0. What makes this one equal 0? If x was 2. And this one would be 0 if x was negative 3 divided by 2, or negative 1.5. Okay, kind of mentally double check. Again, this is not a log equals log, so we're not looking for them to be equal. Okay, we're just trying to double check, make sure they stay positive really with this. So if I put 2 in there, 2, 4 minus 1 is 3, so positives. If I put negative 1.5 in there, negative 3 minus 1, also going to be negative. So that's going to be a no-no. So we had, that'd be log base 6 of negative 4. Okay, those are both negative, not positive. So we're going to say no to that one, yes to that one. Okay, it's not always the negative answer is a no-no. Sometimes both work. Sometimes the negative answer works and the positive one doesn't. So don't get in the habit of always crossing out the negative one. Natural log of 7x minus natural log of 3 equals 5. Okay, natural logs are still logs, so we can put them together with our log properties. Minus goes back together with division. Okay, natural log is technically log base e, so we can look at it like this. 5 is the power of e that equals that. Or we also talked about exponentiation, where you bump both sides up as a power of e. E and natural log cancel out. (7x over 3 equals e to the 5th). Okay, now you could do two steps here. You could times by 3, divide by 7. Or you could do it all at once, times by 3/7. Alright, 3 divided by 7 times second e to the 5th power. 63.605, that's 3 numbers. The 4th digit's a 6, which bumps the 3rd digit up. So 63606. Last one. 2 to a power equals 5 to a power. Okay, a lot of times we see these problems, we're going to try to rewrite them as the same base. So try to get them both to be 2s to a power. Try to get them both to be 3s to a power, something like that. Okay, I cannot change 5 to be 2 to a power. Alright, so when that happens, we're going to look at using logs. We're going to log both sides, because log has the power property of logs, which allows you to then to take the exponents down in front as a multiplier. So we would have 3x times log of 2, and x plus 1 times log of 5. Okay, then this has a parentheses group here. We're going to distribute this out, break that one up. Alright, x times log of 5 plus 1 times log of 5. Okay, that one has an x, that one has an x. Let's get them both on the same side. Combine, not necessarily combine, but like get your x's on the same side at least. Because these are not the same log, log 2 and log 5, so you cannot combine those. Alright, we got x's on the same side. Everything on the left-hand side has an x, so we can factor an x out in front. Take that x out in front. Okay, now if you want to get really fancy, you could use your log power property in reverse to put that 3 back on top of 2. 2 to the third power is 8. Then we have a minus, so we can put these together with division and have log of 8/5. And then divide both sides by log of 8/5. Okay? That, I think, that's perfectly mathematically correct and legal. It just gives you a couple more steps that you would maybe make a silly mistake on. So my preference here is to just divide by this parentheses. Okay, divide by those parentheses. A couple different ways to type this in. Okay, without using the fraction bar, you're going to go log of 5, close your log parentheses, divided by, and now we have lots of things going on down there in the denominator, so we need to do a parentheses so that it does all that stuff first and then divides by it. So parentheses, 3 times log of 2, close your log parentheses, minus log of 5, close your log parentheses, and then another closed parentheses for that open parentheses. You can also use your fraction bar. Alpha y equals first one. Okay, now you got a fraction bar. It really just eliminates the parentheses for around the denominator, because the fraction bar is going to automatically do that and separate them out. Okay, so we have log of 5 on the top, close those parentheses, drop down 3 times log 2, close the log, minus log of 5, close that log. Got to close those log parentheses. Okay, 3.424. Alright, there you go. You guys got the right hand side, and answer key should be on. Oh, well, left hand side's done. Yeah, you have the right hand side to go. That's it. Okay, and then you guys have that rest to do on your own. Answer key should be posted. Good luck.